All right. Thank you, Amy and Jamie. Uh, who wants to hear more from Jamie? That was pretty good, right? Yeah. You guys are in luck. She's going to come back later for another panel on AI in the enterprise. So that's not the first time you're going to hear from her. Moving on to our second keynote, however, this will be moderated by Manish Kumar, who's the director of the MIT Bitcoin Expo. And the keynote's going to be a virtual fireside chat with Emad and Mostaque, the CEO of Stability AI. Who here has heard of Stability? Yeah. I mean, if you're a builder or developer, I mean, this is like foundation work on generative imaging, right? So, I mean, Ahmad's going to bring a lot of insights on what it's like to build open source, what it's like to build in these other modalities. I think you guys will learn a lot from him. So please welcome me in welcoming Manish. And do we have Ahmad ready on the Zoom? There we go. All right, over to you.
I'm excited to introduce our next keynote speaker and the CEO of Stability AI. Stability's mission is to activate humanity's potential using generative AI by providing open models in every modality for everyone, everywhere. Please welcome Emad Mostaque.
Thank you for having me today.
Yes. How you doing, man? Thanks for joining us.
I'm doing all right. It's busy as always in the AI field.
Yeah. So in not so long amount of time, you've kind of become like the OG of open source AI. And I want to get your perspective. We're big on open source here at MIT, and I want to get a better understanding of why that mission is so important to you.
I think that the foundation of this big generative AI shift has been on open source, open models, and open models are required for a whole variety of things, from customization of your own assets through to every government regulated industry will be run on open models. Because the best way to think about these models, I think, is they're like graduates that try too hard. And occasionally they hallucinate, but they can code, they can write, they can do all this stuff. And what you have is proprietary models like consultants that you borrow, but then these models will be inside your systems, and no one's going to want to have a proprietary model for that. They'll want open models that they know how they work, they know the ingredients that make it up. And so I saw there was a path to providing very high quality open models that people build on and then just stoke innovation.
Yeah, on campus I've heard that some of our labs were kind of thanks to this open model. You even open up your weights to your models. Tell us about why and what you hope to happen in the future with that.
Yeah, so I think open source is interesting because you have the source code and then you've got the data sets and you have the weights. And so for our language models, for example, like Stable LM2, which performs up at Llama 70B level on a laptop, we release the code, the data, and the weights. Others, like Mistral, release the weights, and those are open weights, but you don't know the source code, you know the data. And you need a mixture of those. But what you see, again, is once you release it, you can take those assets, you can optimize them. So we've seen like orders of magnitude improvement in the speed of Stable Diffusion, for example. You've seen people try and optimize the data sets, try new things, have control nets, and the whole ecosystem built around that, just like they have around Llama. And I think that's incredibly powerful, this pace of innovation to address real world needs, whereas you're a bit more limited with proprietary models and what you can do.
So we've seen companies go, start as open source and then go closed source. You're just on, you've really been championing the open source. Can you tell us a little bit about the pros and cons of the decision of doing either?
Yes, I think open source has been infrastructure, and there's a question, is this technology infrastructure? And I believe it will and should be. And we have classical open core models like Red Hat Linux and others where you have open source and then you build around that consulting businesses, etc. I think that the reason that a lot of companies went non-open source is partially there was the AGI discussions and other things which are a bit complicated. And also because once things are open, like Mistral release a model one day at $2 per million tokens, someone else does it at 30 cents a token, it's difficult to have a classical business model when things are moving this fast. What we did is we moved to a membership model because in 2 years we've had 200 million downloads of our models, and now we have the best models of almost every type apart from large language, from code to 3D to audio, where it's a flat fee for all our models. So it's a bit like Amazon Prime. So that way we can grow with the market. And it's going pretty well, but it is difficult because you don't need that many open source providers, you know? And already people are moving beyond the base models to that next layer above of abstraction.
Yeah, that's a great segue into my next question. So talking about advancement in models, we had some great news coming out of Stability AI this week that you folks published your new research paper, Stable Diffusion 3. And can you tell us a little bit about that, the new innovations, what can expect going forward, why it's so important?
Yeah, so I think, we pioneered with Robin Rombach, Patrick Esser, the Stable Diffusion team, Catherine Krausen, the diffusion models, and then the parallel track was these transformer models on the language in particular. And so we have some of those too, but this next generation of models are diffusion transformers that mix the best of both worlds. So that's what's used in OpenAI Sora model, for example, which is kind of amazing. And we've released a new architecture called multimodal diffusion transformer that powers just Stable Diffusion 3. So Stable Diffusion 3 already now before being finished, and we expect the weights out, I don't know, probably in a few weeks, a month or so, already outperforms every other model, including Midjourney on the market and DALL-E 3, because it leverages this technology to allow it to scale and also to have high degrees of accuracy. But the same architecture can accept audio, video, text, any modality. And this is incredibly interesting for where we're going, because the models that we've had so far across the board have been largely filled with junk and not optimized. We're using research artifacts in business. Once we standardize around a few architectures, and we believe diffusion transformers will be one of them for media, we can then get to the optimization equation, and there's actually potentially orders of magnitude improvement in speed, quality, and output that can come from that. And so we're super excited around that.
So what are you thinking about? Like, if we're thinking about what this new research means to what's coming out of Stable Diffusion, can you give us some examples as to the improvements that we'll see?
Yeah, so we had Stable Diffusion, then we built a system called Comfy UI that can bring different models and control nets to it. So you have the base model, and then you can control the output, adjust it, etc. The technology coming to Stable Diffusion means that it now has amazing typography. It has amazing kind of situational awareness and presence and permanence. So you can see a red ball with a blue hat on top of a avocado wearing a tiara, and it understands all of that straight from the base model. And then as you build pipelines from that, and you have discriminators and adjusters, it means that we're moving towards pixel perfect control. So I think the paradigm is we have amazing models that can create, then we have a control layer, then we have a composition layer, and finally a collaboration layer to really drive those amazing user outcomes. And so it's like you program assembler code, then you build libraries, and then other patterns on top of it, and finally you can build amazing apps. We're moving up that stack right now.
That's awesome. So with all this new innovation, in past interviews, you've said that you can see about 5 years out into where we're headed with the AI future. And a lot of our audience today are going to be entering the workforce, whether they're graduate students or undergrads, in this time period. You've also talked a lot about what maybe like changing a curriculum for where an AI-assisted future might be the best way to kind of grow your own skill set. Can you talk a little bit about where we're heading in the next 5 years? What are some of the bottlenecks and some of the milestones we have to reach, and what that might look like?
I think, as I mentioned earlier, the best mental model I've had for this is over-enthusiastic graduates right now. Again, that's hallucination. You wouldn't trust a graduate with a lot of these things, right? But they can be very good. I mean, there's a lot of great graduates in the audience right now. I think that's how you can think about it affecting your personal life, your business, and others, because that creates a massive supply, especially in knowledge work, of these graduates versus, the demand is going to be relatively stable, growing a bit. So when you're thinking about that future, you have to think, how can I leverage this technology to build organization systems and more that can both help me achieve my personal thing or build businesses or contribute to businesses? Because the pace of this technology coming, just had Microsoft, they've adopted it amazingly quickly. Now they're a $3 trillion company, right? Is such that every organization can be massively improved by this technology. You don't need to create new organizations. You can improve existing ones. Like MIT is an amazing place, but people still feel frustration around information flows. What if you have more graduates in MIT working for MIT on MIT things like organizing papers and all sorts of other stuff? Life would be easier. So I think it's just diving into using this technology, adopting it from a design perspective and thinking about the systems of information flow and how to improve them. One of the things I like to say is that AI can't do art. It can make content. Humans do art. AI can't program. It can write boilerplate, you know? And so the role of the person is that next level above, utilizing and leveraging all of these assets to create real world outcomes. And that's what you should be thinking about, and that's what you should be focused on.
That's great. So compute, you have sort of an infrastructure company, right? You provide infrastructure for these open models. And it seems to me that this infrastructure race is, we have the NVIDIA sort of bottleneck. And then along with that, we have Qualcomm and with their Snapdragon, Intel with their Gaudi 3 and AMD and, all the usual players kind of trying to catch up or like create a more competitive market. Lately, even the Grok LPU, people are really trying to figure out how to get around this bottleneck. In India, I saw Bhavish Agarwal. He is trying to just create his own GPUs to avoid this infrastructure kind of issue. So, talk a little bit. I want to talk shortly about this broader GPU race, and then I want to follow that up talking about computing on the edge. So, if you could start with the first part of that.
Yeah, so I think the GPU thing is quite interesting. I've been a big advocate of being long GPUs. We have over 10,000 A100 equivalents. That makes us one of the larger players out there. But we try everything from TPUs to Gaudis to these other models. Ultimately, the processes for training and running these models are not complicated things. It's matrix multiplications or diffusion kind of things. And we use general purpose processors. But in the first stage of this, what we did is like, when you take a crap quality steak and you cook it for longer, it becomes nice and juicy. We took the whole of the internet that we could see and used rubbish data with big compute to achieve these outcomes. So one of these models aren't insane. Now when you look at Phi 2, when you look at how DALI 3 or Stable Diffusion is built, we're using synthetic optimized data and requiring a lot less compute. And so I think that you're seeing diminishing gains with exponential compute. I think that you're seeing now standardized base models that you can build around. And you see that actively because GPT-4 Claude are amazing, but they prefer to fine-tune a Mistral because it does the job. So I think it's a satisfying thing on the large model training. At the same time, Stable Diffusion XL, for example, took 20 seconds to run on a 4090 when we released it last summer. Now we can do 200 images a second if you look at Stream Diffusion. You're seeing orders of magnitude improvement. And again, the quality of what you can get now is crazy. So if you download lmstudio.ai and you run Stable LM2, you can run 100 tokens a second for a Falcon 40B level model on a MacBook M2.
Wow.
And that's kind of crazy when you try it. Like, this is slightly magic, right? But they're still not optimized. So when I look at the equation, what I see is that language models will get to a GPT-4 level on the edge, probably in a year or so. And that's good enough for 95% of use cases. And it's a big race to zero against Google and others with their millions and millions of TPUs, which are actually very good chips. Then on the other side, what you see is that we can already generate every pixel. Like for $15 a month right now in compute, I could do 100 hours a month of cats with hats of various types, and so that's, good enough content for most people, but we'll have video generating every pixel, as Jensen said, in a few years. So I think most of the compute will be pushed towards the edge, except for the super expert systems like the multi-million token window Geminis, etc., which are also amazing. And then most of the compute otherwise in the cloud will be used for streaming of media. I think that's a very different paradigm for everyone expecting large language models to be everywhere. I think large language models will be on your phone, on your laptop, for 90-95% of use cases, and then call into the cloud for the super expert stuff.
That's really interesting. So I want to talk a little bit more about that. When it comes to moving to the edge, you've often talked about what that might mean for all of us. Can you, fill us in again about what compute on the edge means for the end user?
It means that you can have, like, a lot of people looked into fully homomorphic encryption and other mechanisms for privacy preserving AI. If you've got a standardized model, and again, the standardization is important. That's why source stability, like Jim Box and Netscape said, there's only two types of companies, bundlers and unbundlers, and we're a bundler. Good quality models of every type that you can build around. Like, you don't need a new games console every so often. If that model is on your device, then you can train it dynamically with all your information. So Answer AI and a few others just released a new set of protocols that allow you on a consumer GPU to train the 70 billion parameter llama model and fine tune it. So now that's within access of everyone. That's just going to get, again, more and more optimized. You don't need 70 billion parameters for 90-95% of use cases. And base models with private data will outperform generalized models, just like that's why we hire graduates and we just don't have consultants all the time. And then it comes down to real world use cases across these different modalities. I have a music library. You take one of our music models and then you have an intelligent music assistant. You have your images, and Apple, I'm sure, will have an intelligent creator that can put your face into any scenario, but really private on your iPhone. So again, I think we need to think about intelligence moving to the edge, and it's super powerful when you think about it, versus the classical internet where all the intelligence was at the center. And this is particularly important when it comes to emerging markets in the global south. A lot of people in the audience will come from outside the US. What happens when everyone has a GPT-4 level smartphone, AI on their smartphone in India or Indonesia? That's a dramatic change in productivity, in capital flows, information flows, and more.
I've heard you say, not your data, not your models. Tell us a little bit about what you mean by that.
Actually, I kind of riffed off the crypto, not your keys, not your crypto, not your models, not your mind. So what's embedded in these models will have a big effect because we rely more and more on these models. Like if you talk to Claude 3, it's amazing. You know, it's just like having a conversation with a real person. And they're getting to that level now where it's just really nice, like that movie Her, maybe. Once they get to AGI, they'll go away and say goodbye and thanks for all the GPUs. But it's like having that conversation. Anthropic had an interesting paper called Sleeper Agents, whereby they program data into the models, and then with a flip, like turning 2025 or DOS for Daniel or something, the model turns evil, and you can't tune that out or identify it ahead of time. You know, so you need models of your own as well as other people's models, because you can't trust them, especially in regulated industries. I think data transparency will be key, and that also makes models safer. But then also because you want it to represent your own view and your own biases, because no technology is unbiased. And we can't just have something where it has one point of view, you know, and again, we have to distribute the benefits of this technology. In fact, you know, like a lot of the things, there's a bit of jingoism about other people can't have this technology. So you're like, when will 1 billion people in China have this technology, you know, and other things like that. So I think open is the way, because this is something that can uplift all of humanity. And you need those models that represent you and work for you, as opposed to misaligned objectives, maybe from some of the other models by advertising companies and others.
Very interesting. So as you can imagine, when I told folks that you were going to be here, a lot of students had a lot of questions. So I actually put some of those together, and we just have a few minutes left here. So I'm going to fire off some of these student questions and give you a chance at them. Ready? A little bit of a lightning round. All right. Do you recommend aspiring founders in the room follow your footsteps, attempt open source ventures? If so, what's one tip to think about monetization?
God, no, don't do it. Being a CEO is terrible. I think that the key thing with open source is you do open source if you want to become a standard, you want it to spread, and you want to leverage community. So my thing was build those building blocks and then other people can build on top. It's very difficult to do the base models, but then you've seen companies like Nous and others take one level above that, which requires far less overhead. And you'd have to look at what is the classical open core business models, because open source is $200 billion and more of market cap. And again, this is about a spread thing. So I think think very carefully, where am I adding value that's sustainable? And how can I have distribution? In fact, that's what I say to all AI founders. Distribution is the most important thing, because this technology can go everywhere. And if you can help a company with good distribution, that's the key and that's the gold, and that's how you can grow amazing businesses.
Okay, it's gonna be a lightning round now. You got a minute and a half, right? So what's one thing you wish more founders worked on?
I think healthcare and education, those two are the biggest. Education by far the largest. Personalized tutors, Two Sigma effect, huge.
Most interesting startup you heard about in the past month?
Gosh, don't know. Pass on that one. I see so.
Okay. What's an industry ripe for disruption by AI?
I would say, again, education. And everyone's education in school has been crap. Nobody in this audience was happy with their school. And personalized tutors and the Two Sigma effect, spoon effect, it will transform education forever.
What's a use case you didn't expect people would hack on with Stable Diffusion?
I think we didn't expect them to be able to do the 3D because you can extend out the 3D representation from the 2D world, and now the 3D is going insane. So we just released TriPoSR that's 0.5 second generation. It's going to get even faster and even better.
Besides image, what are some other modalities you're most excited about?
I think I'm most excited about the 3D. I think we have a real chance of building that holodeck, we take the Vision Pro, and we'll be generating real worlds live in a few years. And that's crazy when you think about it. Also, the other one is audio music. Music's going to be transformed forever this year.
Yeah, I just got my young nephew on your Stable Audio, and he was really blown away. So last one, Manchester United or Chelsea?
I'm going to go with Chelsea as a London boy, even though I'm a Tottenham supporter. But Man U, nah, never.
Thank you so much for joining us today, man. We really appreciate your time, your wonderful insights, and we're grateful.
Thank you. Take care, man.